Hi guys, welcome to this video. Today I'll introduce you guys about Pascal's triangle, and Pascal's triangle and binomial theorem. And then use these techniques to solve problems. Okay. So let's first look at Pascal's triangle. So basically, Pascal's triangle, you have 1 on both sides, and this is the 0th row. And remember this. And okay, so these elements, the second element on each row, second element is n choose 1. The second element is always going to be n choose 1, which means the third element, is going to be n choose 2. And the nth element is n choose n minus 1. Okay. So let's continue. This 1 is really bad. This will be 4, 6, 4. This will be 5. And this will be 5, 10, 10, 5. Be 6, 7, 8. 6, 7, 8. And this is 15. This is 20, 15. And this is 21. This is 35. This is 35. This is 21. And this is 28. And this is 56. And this is 70. And this is 56. This is 28. Which means that this is always gonna be n choose 0. And these ones are always gonna be n choose n, because n choose 0 there's only 1, and n choose 0 there's nothing, so there's only nothing, which is n choose 0, right? And 1's gonna be forever. And let's just randomly pick out a length. Then let's see if it's 5, 10, 10, 1, 5, 10, 10, 5, 1. Then 1 is equal to 5 choose 1, and 1 is equal to 5 choose 0, and 5 is equal to 5 choose 1. 10 is equal to 5 choose 2, and 5 choose 3 is also 10 by symmetry, and 5 choose 4 is 5, and 5 choose 5 is 1. So basically, and this is in the binomial theorem. And the binomial theorem basically states that a plus b to the nth power is equal to a to the nth power plus n choose 1 times a to the n minus 1 power times b, and plus n choose 2 times a to the n minus 2 power times b squared, and blah 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 blah, and n choose k, and in the kth term will be n choose k times a to the n minus k's power plus b to the kth power. So blah 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 blah, and continue for all. Then we're gonna finally have n choose n minus 1 times a to the n times a times b to the n minus 1 power, and plus n choose n, which is 1, so that we don't have to write this, which is, and then lastly we have b to the nth power. So this is the whole binomial theorem, and this is pretty useful in problem solving. Let's say if we want to find what is 2001, no, let's say what you find 2011 to the 2011th power, you find the 100 digit, then for this, it's gonna be pretty easy. We'll use binomial theorem. So basically, we can write this in expansion of this. Then we first want to look at 2011, choose. Then now we just want to look at the last 3 digits. So first, let's look at 2011, choose 3 times, no, actually no, 2011 choose 2, because 2011 choose 2019, which is basically just equal to 2011 choose 2, which will end in 5. And this is basically just, and we can write this as 2010 plus 1 to the 2011th power, right? Then this is basically 2011 square, which ends in 1, and 2010 square, which ends in 10, right? 100, and 1 to the n power is just 1, right? So, and then we can look at 2000, and then we also want to look at 2011 choose 1 times 2010 times 1, which is 1 times 10, which is 10. 1 times 10, right? Which 1 times 10, which is 110. So we get 5. So we just want to look at our last 3 digits. So which means this will end in 600, and we want to add the lastly 1, right? 1 to 2011, which is, and we plus 1, and we get 601, right? And we only want to look the 100th digit, so which is 6. And this is our solution. You can see that this is really helpful in solving some problem that looks really hard. So now let's introduce another identity. Let's draw the Pascal triangle again. Let's go back to the Pascal's triangle. Then we draw dot, 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 dot. And this is gonna be the nth row, right? And when we remember the fundamental formula, the sum of all elements in nth row is 2 to the nth power. This is gonna be the sum of all elements in nth row. So let's just try one, right? Let's just try 1, 5, 10, 10, 5, 1, right? This is the 5th row, and we add this, we get, this is 16 times 16 times 12, 2, which is 32, and this is equal to 2 to the 5th power, right? And this makes us a formula that n choose 0 plus n choose 1 plus n choose 2 plus blah 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 plus n choose 19 plus blah 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 blah. I don't even know why I choose 19 as my one number. N choose n minus 1 plus n choose n. This whole term is basically just equal to 2 to the nth power. It's pretty simple, right? This is basically just equal to 2 to the nth power, okay? This is pretty simple. And we also want to remember that this is also symmetrical. If there's a middle number, then this will be just, then we just find each half of them by just dividing by 2, right? So let's say if there's a problem such that the sum there's a function such that f of n is equal to sum of n plus 1 row sum of nth row the sum of the nth row elements. So f of n is equal to the sum of the elements in the nth row minus all of the elements, sum of all of the elements in the number row less than n. So let's say if it's in the second row, no, it's say if it's fourth row my third row. So fourth row is 14641, which is 16. And this we get 8 plus 2 to the third is 8 plus 2 to the second is 4 plus 2 to 1 is 2, 1, which is just 1. Then this is what they're asking. And let's find the minimum value of f of n if n is larger than or equal to 10,000. This problem looks weird and looks pretty hard, but actually it's just simple. So we want to memorize this formula that a to the n minus 1 is equal to a to the 2 to the nth power minus 1 is equal to 2 to the n minus 1 plus 2 to the n minus 2 plus blah 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 plus 2 to 1 plus 2 to the 0, which is 1. Okay, so basically by using this trick, then we know that whenever n is any number, even n is equal to this such large number, blah blah blah, okay, then f of n, by using this trick, f of n is always gonna be equal to 1. Thank you for watching. See you next time.